Hey there, fourth graders. Well, yesterday went as well as could be expected. Actually, it was today because it's nighttime. Yes, I can tell because it's dark outside. And I'm a little scared. No, I'm kidding. Um, so, tenths and hundredths. I'm not lisping. I'm actually talking about decimals. So, what we're going to do today is kind of regroup on the tenths and hundredths. And what I mean by that is I'm just going to give you another explanation about it, not assuming that you get it, because I know it's a little bit of a stretch. It's kind of abstract thinking at its finest. And so I'm going to give you an opportunity to look at this. And so we're going to call this tenths and hundredths there and back again. It's true. I'm going to give you a little bit of a review. You'll be fine. I think you'll like it. So this time, instead of using that annoying meter stick that we can't have in our hand because, well, we're not in the classroom, we're going to use a grid. Now, from my perspective, this is actually a better tool because it's easier to see, and it really does get the point across about how you convert tenths to hundredths. And that's really what you wanted to get yesterday in lesson 4. And so I think this is going to basically drive that point home. So I've got tenths and hundredths. You notice them there on the left and right of that big white triangle. How about a rectangle, Mr. C? Yeah, that works better. Triangle has 3 sides. Through the power of shading, I'm going to shade in 3 of those tenths. Yes, I said that. That's 3 tenths. And then I'm going to say, okay, well, what would happen if I shaded that same portion of the whole over in the hundredths grid? What's that look like? Well, it looks just like this because I did a direct copy and paste. And so if you were to count all those little tiny squares up, you know what you'd get? Yeah, I wonder too. Actually, I know. It's 30. 30 hundredths. 30 hundredths is the same as 3 tenths. Why? Well, you see it right in front of you. That's why. And I know you're asking, but how? Well, remember how we used to make equivalent fractions? Oh, way back yesterday. And I'm going to show you how to do this. And you know that, okay, 3 times what is 30? Well, 3 times 10 is 30, which means you have to use the fraction 10 tenths because that's equivalent to 1. Yes, I know I'm going back over some things you probably know in a really solid way, but that's okay. And so 3 tenths becomes 30 hundredths. And these are equivalent fractions. Yay! Yes, we need more of those. Partly because it's a math lesson that I think you'll get, and partly because it's the last day before spring break. I'm so stoked. I bet you are too. I don't know what I'm going to do. I may do nothing but read. I know that some of you are going to cringe when you hear that. Not Cassidy. I gave Cassidy 4 books. Let's see if she's up to the 4-book challenge to finish 4 books from The Ranged Apprentice before Mr. C does. Yes, I'm going to go ahead and bet my money on you, Cassidy. I don't know who's going to pay off that bet, but I'm still going to bet on you. Anyway, here we go. A little bit more. Now, I've had to reorient this drawing just because it cuts off a portion of it and actually makes it fit better for the purpose I'm going to use it. You haven't lost any of the grid. You haven't lost any of the little tiny squares. But I have shaded in 50 100ths. And what I'm going to do here is I'm going to go back in the other direction. I'm going to show that 50 100ths is equivalent to 1, 2, 3, 4, 5 tenths. How do I do that? Well, divide top and bottom by 10. Divide by 10 tenths. Why would you do that, Mr. C? Well, because I'm trying to go from hundredths to, hang on, got to change the color of my pen. Hundredths to tenths, just like that. That's why I did that. I'm going to divide by 10 so that I end up with 10 in my denominator. Why would I want to do that? Because I'm actually just trying to get rid of that crazy 0 on the end. And so that's what I did. I know, that's kind of like math magic trickeration. Don't memorize that. Just know that I did it. That doesn't make any sense, Mr. C. I know, but the 4th graders, they believe that stuff. Okay, shh. Anyway, moving right along. Another example. Okay, Mr. C, that's not fair. What do you mean? Okay, so you only partly colored in one of those columns in that drawing. I know, I did. So I have 40, and so that would account for those first four columns that have 10 each, and so that would actually end up being what? 40. 40 plus another 6. Yes, if you want to count those, it is 6. So 40 plus 6, 40 hundredths plus 6 hundredths is 46 hundredths. Now, I want you to look at this in a slightly different way. I'm now bringing in the tenths grid because, well, I think you might have thought that I was going to let that go, but actually it's an important part of the lesson today. And you actually had a taste of this yesterday, so this is not really breaking any new ground, so you should probably be okay with it. But you see that the 40 hundredths is the same as 4 tenths. It covers the same area. And we've already shown equivalency on the previous slide. And so I think we're good to go. At least I'd like to think we are. Oops, take that back. Anyway, so what I'm showing here is that I have, on the left-hand side, I have 40 plus 6 over 100, which is 46 hundredths, is the same as 4 tenths plus 6 hundredths, which is also 46 hundredths. That's 4 tenths. That's 6 hundredths. I'm writing it out in word form because I want to make sure you understood what I said, and I really want to reinforce the idea that the words are just as important as the numbers because you call them by those names. And it actually, believe it or not, helps you understand and remember the decimal place value names. Anyway, 46 100ths is the same as 46 hundredths written as a decimal with 2 place values to the right of the decimal. Yes, I said 2. And if you recall from yesterday, what was important about that was you have 2 zeros, which means that is 2 factors of 10. Yes, 10 times 10. And so that's why you had to move the decimal point, or actually move the digits 2 places to the right of the decimal point. And that's what happened. Wait, what? You may still be saying this because some of you are going to say, okay, well, I sort of kind of faked my way through it yesterday. Mr. C didn't want to tell you, dude, but that's what it did. Hopefully that's only a couple of you, but it does happen. And if it didn't, fantastic. And you guys are my heroes. Onward. I believe this is the last slide. Oh, and just for the sake of discussion and illustration, I also wanted to point out that those values converted into decimals look like that. And once we get to the point of adding these kinds of things, and we will, it'll seem like old news, and you'll say, okay, Mom, see, I got this. This is just a piece of cake. And decimals, like a decimal cake. As long as it's chocolate, I'm down with it, okay? Anyway, we've got one more piece here. Yes, I've just messed up my own drawing. Let me go back and redo that. Come on, Mr. C. Okay. So what I wanted to point out here was that you have tenths. Right there. 4 tenths. And you have 6 hundredths. Right there. Yes, that digit 6, or 6 digit, take your pick, is in the hundredths place. Because it's 2 place values to the right of the decimal point. I'm going to say that till you're really done hearing it. It's like, no, Mr. C, please don't say it again. Finally, our last slide is devoted to practice. 36 hundredths. I think you already know what's coming here. Yesterday, you were asked to write this with a number bond. I prefer to use an expression. And so this is the expression I'm going to use. I'll show you after I get these done. So there's 36 hundredths. You know how to write that as 36 hundredths, I hope. And there's 75 hundredths. So I'm dividing by 100, and that means the numerator loses, in quotation marks, 2 place values. Does it really lose 2 place values? No. But you actually reduce the value of the number by 2 place values. That's pretty abstract for a 4th grader, so you may not quite understand that. And I can forgive for that. That's not a big deal. We'll get there. So that's how you accomplish this using a decimal pattern. In other words, 36 hundredths is equal to 36 divided by 100 is equal to 3600ths. It does work like that. It would be useful to have this mastered because next year you'll see this all over again. Guaranteed, because I taught it to the 5th graders this year. Now, if you take that same number and you play it out in terms of fraction, decimal, and word representation, they all look like that. There's a commonality there. This should start to feel more familiar. And trust me when I tell you, when we get back from break, yes, you're going to have about a week and a half to forget it. We'll come back into this and you'll say, it's okay. Your brain is designed to forget things like this. And the reason that is because it's asking for repetition. And believe it or not, and this is the cool part about learning, is that you're going to forget this, but or at least forget part of it, but when your memory is refreshed, you'll actually know it better the second time around. So that's something to look forward to. Anyway, that's all I wanted to say, except for one thing. I'll try this again. You could take this and say, okay, Mr. C, that's awful. You could take this and say, okay, Mr. C, I'm still not quite savvy to when you have 3/10 and you have 600ths. Mr. C, those are not a common unit. And what I would say to you is, well, you know how to make these into a common unit, and that's what I would have you do. And yes, I'm perfectly okay if you say something like this. Oh, Mr. C, that's right, because I multiplied top and bottom by 10, and that's how I end up with my 3600ths. That's just kind of a little sidebar as we're leaving the lesson. So, right at 12 minutes, I'm going to call it a lesson, and if you have questions, please let me know. In the meantime, have at it. Get those problems done. Talk to you soon, and thanks for listening, y'all.